look at how do we represent the concentration of an acid or base in solution. Concentration means how many molecules per unit of volume do we have in there. So sometimes it might be a strong acid that we're working with, but if we water it down enough, then it's not very dangerous. So the concentration can be very important. And we measure concentration in a unit called molarity. Molarity, and that is defined as the number of moles per liter. Now we've already learned about moles, and we even already know how to calculate moles from grams. So there's two kinds of problems that you might see with this kind of subject. And one is the problem where I ask you to figure out the molarity when I tell you how many grams we have and I tell you how many liters you have. The other kind of problem is that I might ask you to find out if I wanted to make a solution of a certain molarity, how many grams would I need to put into the solution. So let's look at those two different kinds of problems. So one is, I will say, to find the number of grams needed to make 2.5 liters of a 0.15 molar solution. So in other words, I know what concentration I want. I want a solution that's 0.15 molar. That means the molarity of the solution is 0.15. That means that it has 0.15 moles per liter of water. So what I'm going to do here is set up exactly what I have here, plugging in what I know and solving for what I don't know. So the molarity is given in the problem, 0.15 molar equals moles. That's what I don't know. I don't know how many moles I'm going to need, so I'll call that X. But I do know the number of liters. That was given as 2.5 liters. So using my amazing algebra skills, I know that if I multiply both sides of this equation by 2.5, then I will have X. So 0.15 times 2.5 gives me 0.375. And that's moles. But notice that the problem asked me to find the number of grams. And, oh, I never told you what solution we're making. All right, let's make a solution of sodium hydroxide. You kind of have to know that. All right, so I know how many moles I need to put in, but if I want to know how many grams, I have to know what I'm putting in there. Okay, sodium hydroxide has a molar mass of 40. Just trust me on that. You can figure it out yourself if you want. So I'm going to take the number of moles and multiply it by 40 grams per mole. That's what molar mass is. So back to the calculator. That turns out to be 15 exactly, which is good because I only have two significant figures. So if I took 15 grams of sodium hydroxide and dissolved it in enough water to make 2.5 liters of solution, then I would have a solution that is 0.15 molar. So that's how you do that type of problem. Now the other type of problem is when they tell you how much you put into water and you figure out the molarity. So let's just make up one of those kinds of problems. So let's just do sodium hydroxide again because that's easy. So let's say that 15.3 grams of sodium hydroxide dissolved in enough water to make, oh, let's say 3 liters of solution. And we're supposed to find the molarity for that. Now, I'm going to just stop for a second and talk about why I word it this way. Why don't I just say that I'm dissolving it in 3 liters of water? Well, because I don't take the sodium hydroxide and dump it into 3 liters of water. I take the sodium hydroxide and put it in the empty container and then bring it up to 3 liters with water. And there's a special kind of container we use called a volumetric flask, which has a really skinny little neck, and it has a mark on it that tells me what the volume is. So I can be very exact about how much liquid I put in there. And that's because of the definition, which is moles per liter of solution, not per liter of solvent. So most of the time that doesn't make a difference, because most of the time the amount of solvent is very large compared to the amount of solute, and we're putting in just a little bit and it really wouldn't change the volume that much. But sometimes it would change the volume. So we have to be very persnickety about this. All right, so back to business. The molarity, which is what we're trying to find out, is moles per liter. So the first thing I have to do is change this into moles. So back to something we already learned how to do, 15.3 grams divided by 40.0 grams per mole. That's going to give me the number of moles. And once I have that, then I can divide it by the liters. So here, let's do this all in one step. Divided by 3 liters. So, calculator, 15.3 over 40. And then divided by 3. 0.1275, I have 2 significant figures, so 0.13. And there is our final answer.